Alright, welcome to part 3, the last part of 2.2 quadratic functions. For this part, same essential questions. What information can we determine from the graph of a function, and what is a quadratic function? So, strategies for solving problems involving maximizing or minimizing quadratic functions. We're going to look at word problems. So number 1, first step, read the problem carefully and decide what quantity is to be maximized or minimized. Step 2, use the conditions of the problem to express the quantity as a function in one variable. Rewrite the function in the form f of x equals ax squared plus bx plus c. Step 4 is to calculate negative b over 2a. If a is greater than 0, f is a minimum at x equals negative b over 2a. This minimum value is f of negative b over 2a. If a is less than 0, f has a maximum at x equals negative a over 2a. Negative b over 2a. This maximum value is f of negative b over 2a. And number 5 says answer the question posed in the problem. So, our example is maximizing area. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximizes the enclosed space. So to decide what must be maximized or minimized, well, we just answered that. It's maximized. So you're looking for the max. Step 2 says express the quantity as a function in one variable. We must maximize the area of a rectangle, a equals x times y. So if you think about a rectangle, here's my rectangle, you have x and here's y. So your area is x times y. You have 120 feet of fencing, the perimeter of the rectangle is 120. So 2x and 2y equals 120. So we want to solve this equation for y. That means I need to divide everything by 2. So I have y equals 60 minus x. I just solved for y. So this means my area is a equals x times y. So that means if this is y, my area is going to be x times y. So I have 60x minus x squared. Because remember, you're looking for the area. So this is how I'll find my area. So step 3 is to write the function in the form f of x equals ax squared plus bx plus c. So if you look back, we have 60x minus x squared. So that means if I need to rewrite that, I have negative x squared plus 60x. I'm going to write this a of x instead of f of x. So calculate negative b over 2a. So I have negative 60, 2 times negative 1. Negative 60 over negative 2 gives you a positive 30. So that's step 4. This means that I have a maximum at 30 feet, because that's x. Now it says answer the question posed in the problem. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. Now we just have to plug that in to our equation. So we had a of x equals 60x minus x squared. So a of 30 is 60 times 30 minus 30 squared. So you want to solve 60 times 30, and then you need to solve 30 squared. So 60 times 30 is 1800 minus 900. So 900 feet squared is the largest area you can have. Make sure to answer the questions below and complete your homework assignment.